This project aimed to emulate common recoil systems in games such as Valorant and Counter-Strike 2 by replicating recoil patterns for various guns. This was achieved using data tables and measuring the offset depending on the player's movement and what bullet in the spray they are. The script we're looking at is the rifle script. It starts by getting all the data table values and putting them into an array, as well as setting up the light and particle systems. The firing functionality, obviously it checks for reloading and if there's bullets in the magazines. How the firing actually works, it gets the start end location from the player's viewport. It then applies a spray pattern by getting what index it is in the current array and applying the recoil. And then obviously there's applying the inaccuracies as well. That is based off the player movement speed. And then finally at the end there is also checks for blood or bullet holes depending on what is hit, and it also has a tracer system so the player can see where the bullet's going. Early on in development I added a quick gun range. This basically spawns the enemies in 10 set locations. It was used to test the guns and the hitboxes in the early development. At the top it displays your score and it can be helpful for people trying to learn the gun system. So the next script that I'm going to show you is the user tracker. Obviously I don't want it to track all the time, so I have to start and stop the tracker depending on if the player is in the course. I also need to be able to bind to the weapons when starting the course, because obviously the player might pick up a different weapon at the start of the course. It also needs to bind to the weapon so it can get all the accuracy stats. Obviously when it stops tracking it needs to reset all the variables so the player can go around again, and during that time it also needs to get all the previously saved data and write to a CSV after normalizing it and making final score. Obviously I need to unbind a lot of delegates if the player does pick up another weapon, and we're now looking at the sight sensing. So obviously there isn't a function just if the player can see an enemy, so I've had to sort of emulate a sight. This is done through shooting a ray sphere that is quite large in front of the player's current position every half a second, and it basically gets every target that is in that sphere. It then fires a raycast every 0.1 seconds to see if there's any objects between the player and the enemy. And if there's not, obviously it's seen, and then it can start tracking, obviously damage, deaths, stuff like that of the target. So the widget we're looking at is the scoreboard. This basically takes all the data from the CSV file and displays it. So you can obviously rearrange it by any stat that is tracked. It has quite a bit of functionality with the sorting, refreshing, and the multiple menu systems. When it's first constructed, it has to bind all the buttons to functions. It also has to read the CSV file into an array so it can be used. This scoreboard controls multiple pages worth of data, so has multiple systems for displaying the data depending on what page the player is looking at. From the data in the scoreboard, it then creates a graph that is a in-engine histogram. This was done through manipulating images. Finally, these are the sort functions for the buttons that have a enum that can sort the data into the different classifications. Obviously some needed to be in reverse order and some needed to be in order, and some used names, so needed to be into alphabetical order, so a unique sorting system had to be made. This is the main calculation for the rating system. It basically takes the normalized score of the bot, it then passes through a Gaussian curve calculation, which basically tries to apply along a Gaussian curve. It then finds the percentile that the player falls in, and then after that the percentile is put into a LUT function, and that gives you a value between -10 and 10. So I'm now going to show you what a simulation looks like in this artifact. The bot would obviously run around the course, shoot all the enemies. The actual automation system would have a start and an end point, and when the bot lies with the start or end, it would start tracking or stop tracking or destroy the bot. Obviously, it would have to go through the 100 bots in the data table and do them in order from 0 to 100, and then it would also loop. It would construct it and passing all the values from this data table to the bot. The next script's the bot controller. All of the values get initialized from an automation system that is implemented. It then uses a point-to-path system to move around the course. When an enemy is detected using the sight sense, it will run the two functions of stop moving and start firing. These are all delayed depending on the variables inputted into the bot. There's also a recoil negation system, which takes two curves, which are also inputted into the bot. They basically divide how much the recoil is. The variety curve was there because all the sprays were coming out exactly the same, and I needed a bit of variation to each bot. And I also have the bullet miss functionality, which when the bot misses a certain amount of bullets, again inputted by the variables, it will reset the aim and have another attempt at shooting. I thought I'd give some other mentions to the stuff that I did for the project too. These were just extras, so animation and rigging for the guns. I did some animated materials for the maps and the menus. I did decal system and particles for the weapon firing to give feedback. I did AI sensors and controls, so I had to learn all about them. I did obviously the level design and the lighting, which I made look all fancy. I had to look into metahumans and how to basically just get the hands from the metahumans, so a bit of 3D modeling there too. Did some obviously more UI stuff. I know I've covered it a lot in my work, but I did some more. And I did an automatic camera system for the camera control.